Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to wrap up our discussion on measures of center of spatial datasets by talking about the last measure that we're going to discuss, which is this idea of central feature. This idea of central feature. So up to this point, we've talked about mean center, which is just the average coordinate in the x and the average coordinate in the y, as a good estimate of what the center of the data set could be. And we talked about median center, which in the case of spatial data sets is actually an iterative approach where we have an internal algorithm that gets an estimate of the center, calculates the distance from that estimate to all the points in the data set, adjusts the location, redoes the calculation for distance, and continues that process until it finds a point that it's confident is the lowest distance from any given point possible, right? It tries to minimize that total distance from every point in the data set. So what we're going to talk about today is a similar approach called central feature. So central feature actually works in much the same way as the median does, in that it's trying to find a location that minimizes that distance to every point in the data set. And actually let me slide up just a little bit so we can have the definition of median center here in comparison to central feature. So whereas median center found a location that minimized the distance to all points in the data set, we made a specific note here that it did not have to be in the data set. Central feature does something similar, but it requires the point to actually be in the data set. So you're essentially finding the feature within the data set that best represents the center. Right, it finds a location that minimizes the distance to all points in the data set. Right, but the idea here is that location and minimizing distance, right, the difference here is that this location is part of the data set. Right, and so if we scroll back up to our little set of sample points here, right, the difference between the median, which is just a theoretical position, and central feature is that central feature is trying to do the same thing that median center did, but it is constrained to one of the 6 options that we have in the data set. Right, so our central feature, the result is going to be one of these 6 points. And the way that it does that is by calculating the distance from one point to all the other points in the data set, adding those distances up, calculating the distance from this point to all the other points in the data set, adding those up, right? Repeating the process to the third point, right? Distance, sum, fourth point, distance, sum, and then looking at all of those points to see which one has the smallest total distance, and that point is going to be our central feature. So rather than going through manually calculating all of those, I want to just go through this example in an Excel spreadsheet. Okay, so this Excel spreadsheet represents the exact same data set that we were looking at before, right? We have our 6 points here. I've just reordered them slightly for convenience. But you can see these are the exact same 6 points, the x coordinate here and the y coordinate here. And so what I've done is each one of these little blocks of Excel here is the distance calculation between a given point considered to be the center and all the other points in the data set. Right? So for example, for this one here, right, this block here was considering point 1 as the center. And then this distance column here is the Euclidean distance, right? Again, that's that x2 minus x1 squared plus y2 minus y1 squared, square root of all of that, right? The Euclidean distance formula that we've talked about before, right? This cell right here, right, is that Euclidean distance formula calculating the distance between, in this case, point 1 and itself, because this block here is considering point 1 to be the center, right? So this cell here would be the distance between point 2 and point 1. This would be 0.5 and 0.1, and so on for this block. And then we sum the distances here in total, right? So this right here is the summation of all of these distances. So the distance from 0.1 to every other point in the data set, right? This block here is doing the exact same thing, but in this case, instead of having 0.1 be the center, we're considering 0.2 to be the center, right? So this is going to be the distance from 0.1 to 0.2, right? This is going to be the distance from 0.4 to 0.2, and so on. And then here, again, right, we've summed, in this case, the distances between all the points and 0.2, right? This one is doing the same thing for 0.3, 0.4, 0.5, and finally 0.6, okay? So that's all this is. This is just calculating, again, the distance from one point to all the other points in the data set. What we want to look at in terms of finding the central feature, though, is we want to look at these total distances here, right? So for example, this total distance here, this 35.33, right? This is the total distance of all of the points from point 1, right? This 24.90, right? This is the total distance of all of the points away from point 3. So hopefully that makes sense. What we're going to do is look and see, well, which one of these has the lowest total distance, right? So we have 35.33, 35.5, 24.9, etc., etc. And if we look at those distances, what we find here is that 0.4, right, has the lowest total distance, 23.38. So because this cumulative summed distance is lowest, that indicates to us that this 0.4, right, this 6,7, right, this point right here, this is going to be our central feature, okay? So again, just to recap, all I've done is I've calculated the distance from one point to all the other points. I've summed that distance up for each point, and then we looked to see which one was the lowest, right? That's how we minimize that distance. So let's go back to our blackboard here. Let's go down a little bit. And again, just prove that what we did is we found the location, right? In this case, it was the point 6,7 that had the smallest total distance from all other points in the data set. So let's go ahead and as our last piece of this activity here, let's go ahead and label our central feature. So we said that our central feature was the point 6,7. So we go 6 on the x, 7 on the y, and we get this point right here. So this right here is our central feature. Okay. And so what I want to do to wrap up this discussion is talk about the differences and why you would choose mean, median, or central feature. So the first big difference comes in the difference between central feature and mean and median. So central feature is an actual representative point in the data set. Right, so that's the first key difference. If you want to pick something that already exists, you're going to want to go with central feature. So a good example of that would be if you are dealing with trying to create or find an accessible location. Say you're trying to host a town meeting and you're trying to figure out whose house or what building is the most accessible, right? You're not going to use mean or median because you want it to be a building that already exists. It has to be something that you already have built, right? You can't build something new. So you're going to want to use central feature because it's going to give you an already existing building that has the minimum distance to everyone else in the town so that on the whole, everybody's walk is minimized. Okay. Median versus mean. So this one is a little bit complicated because they both kind of try to get at the same thing. The key thing with median is that median is going to give you the most accessible location. So it is going, again, because of the way that the calculation is structured, right? Just like central feature, median is trying to find a new location, right? So again, let's say you were trying to build a new town hall, right? So you aren't trying to use an existing building, you're trying to build a new one that would be the shortest possible walking distance for all of the residents, right? In that case, you would want to use median because you're looking for a new location. So central feature finds an existing location that's most accessible. Median center will find a new location that is most accessible. And then mean center is good if you're trying to track the changes in distribution over time. Mean and median are very similar. The key thing with mean, though, is mean is not going to guarantee you that that distance is minimized, right? Median guarantees you that the distance is minimized. Mean does not give you that guarantee. So if you're talking about accessibility, you probably want to go with median. If you're talking about just trying to measure the changes in distribution, you're probably going to want to go with mean. And if you need the feature to already exist in the data set, then you're definitely going to want to go with central feature. So hopefully that made sense, right? Mean tracks changes in distribution. Median finds a new location that is most accessible. And then central feature is going to find an existing location that is most accessible. Hopefully that made sense. And as always, if you have any questions, please reach out. Thank you.